Welcome to Mobile Coding Academy. Learn principles, build confidence. Let's dive in.
Um, think about a city intersection where the traffic lights are completely out.
Oh yeah, pure anxiety.
Right. Chaos is terrifying.
Mm.
Cars are like inching forward. People are honking, occasionally scraping bumpers.
And that exact chaos is what is happening inside your app during a race condition.
Exactly. So welcome back to this Mobile Coding Academy deep dive. We've already covered why threads exist and exactly why updates get lost in shared state.
Yep, the collision problem.
Right. So today, looking at the notes, we are figuring out how to actually install the traffic light, the Mutex.
It is the natural next step. I mean, once you realize that shared state causes collisions, you know you need a way to orchestrate the traffic.
Yeah.
But the way a Mutex actually achieves this usually catches developers off guard at first.
Well, I can see why. Because as a developer, my instinct is that I need to lock the data itself. Right?
Yeah.
If I have a shared bank balance variable, I want to wrap a shield around that specific data point. But a Mutex doesn't actually do that, does it?
No, it doesn't.
Are you saying a Mutex locks the code instead?
Exactly. You are hitting on the biggest misconception right out of the gate here. A Mutex protects the critical section, which is the specific block of code performing the update.
Oh, wow. So not the data.
Right. Think of it like a single key to a coffee shop bathroom. It just ensures only one thread enters the room at a time. It doesn't magically freeze the plumbing if someone tries to break in through the window.
Okay, let me play this out. Say I have thread A using the Mutex correctly to update the bank balance.
Doing everything right. Yeah.
But then thread B is running some other poorly written function that just directly edits the balance without checking the Mutex first.
A rogue thread.
Yeah. Thread B can still corrupt the data, right? Because it essentially bypassed the intersection and just drove through a field.
Spot on. The Mutex only provides safety if all your threads agree to follow the traffic signals. It's a strict protocol, not an impenetrable shield.
So it's almost an honor system.
Essentially, yes. If a rogue thread ignores the protocol and modifies the shared state directly, your data is compromised.
That makes total sense. But here is the part that feels like a step backward to me as a developer.
What's that?
If I have this beautiful multi-threaded architecture, and then I force all my threads to queue up single file to pass through this Mutex, my app just got slower?
It did.
Doesn't that completely defeat the purpose of using multiple threads in the first place?
It does feel counterintuitive, right? To spin up threads just to make them wait. But inside a critical section, you are intentionally trading parallelism for serialization.
Wait, intentional serialization?
Exactly. Because in this specific context, slower actually means correct.
Okay, slower means correct. I guess running incredibly fast but generating lost updates isn't an optimization. It's just a very fast bug.
Exactly. System design is entirely about trade-offs. Correctness fundamentally has to beat speed when you are mutating shared state.
Yeah.
I mean, if you corrupt user data, nobody cares how fast you did it.
Fair point.
Yeah.
So if thread A is holding the key
Yeah.
and threads B, C, and D show up, rule check.
Yeah.
Do they just stand around doing absolutely nothing?
Yes, and that is perfectly fine.
Really?
Waiting is a completely normal, healthy part of concurrent programming. The Mutex exists to be the bouncer, ensuring threads wait patiently rather than trampling each other's work.
Okay, but if correctness is paramount, why not just wrap the entire app in one giant Mutex? Like, just lock everything to be completely safe.
The temptation to overlook. If you do that, you have essentially built a single-lane bridge for a 10-lane highway.
Oh.
Your throughput drops to near zero. Thread contention is a real architectural cost. When multiple threads are fighting for the same Mutex, the system has to manage that queue, and that overhead adds up.
Because the longer a thread holds the lock, the longer the line gets behind it. We are creating a massive bottleneck.
A necessary bottleneck, but yes, one you must minimize. The art of using a Mutex is keeping that critical section, the locked code, as absolutely small and fast as possible.
Got it. You get in, update the state, and get out.
Right, you only serialize the exact moment of mutation.
Okay, so to synthesize the core intuition here for you listening, a Mutex exists simply to serialize access to critical sections.
Yeah.
We aren't locking the data, we are locking the operation. And we do it because forcing threads to wait their turn is the only way to guarantee correctness.
Well said. You give up a little bit of performance locally to guarantee the integrity of the system globally. Correctness always beats broken, chaotic speed.
Which leaves us with a massive cliffhanger for you to ponder before our next deep dive.
It really does.
If these threads are politely waiting in line, How does that actually work without freezing up your entire app?
That is the big question.
Like when a thread hits a red light, what actually happens under the hood so the rest of your app can keep running? How does the system handle this waiting room?
We will finally bridge this intuition into software engineering next time.
Exactly. In our next deep dive, we will see exactly how a mutex is implemented in Kotlin Coroutines. Until then, keep your critical sections small.
Thanks for learning with Mobile Coding Academy. See you in the next deep dive.